Hi everyone, Phil from Tech for Techs. Today we're looking at this from GELID. It's basically a PCI slot cooler. So what you basically do is slot it just below your graphics card and it'll push fresh air up into your graphics card. We're actually going to test it to see if it does actually cool your graphics card down or if it actually causes more problems than it's worth. I'm guessing it's going to be the first option, but who knows. Again, if you're wanting this product, we do have links in the description just below. That will take you to the cheapest price available in your country. Okay, so we're looking at this GELID Solutions PCI slot fan holder, dual slim 12 UV blue fans, which if you're not familiar what UV stands for, ultraviolet means the fans will glow bluish in the dark, which may work for you, may not. I would have preferred just plain black fans personally, but hey ho. And you can see what it looks like there. Not much information on the front, but it's supposed to basically blow cool air onto a cooler, so onto your graphics card. So for example, you've got your graphics card in your case like that, you'd position this underneath it and it'll blow fresh air into your graphics card to make sure it gets even more cool air. But would it actually cool it down any more? Or would it have a negative effect on the machine because it's causing air to blow upwards from the bottom of your case, which may already be a hot coming from your power supply, or it may affect the airflow of the rest of the machine because the air usually travels from front to back. So we'll find out in a few minutes. We'll test it inside a machine. But let's have a quick look at the case. So on the side it tells you high airflow. It's got a 5-year warranty, which is always good. And on this side you've got 5-volt start voltage, and you've got a you've got silent operation on there as well, so it's very quiet apparently. And then you've got even more information down there as well. It's got a wide cable connector, whatever that means. I know it means 2 to 1, but what type of connector? Is it a 4-pin, 3-pin? Is it Molex? Who knows? But we'll have a look at that. So it's telling you the colours and dimensions and everything else in there, but the basic dimensions are 254mm by 43.7 by 152. It takes up 1 PCI slot. PCI slot mounting screws comes with 2, and then the weight is 238 grams, so not very heavy to be honest with you. So let's open this up and find out what we've got. Okay, so this is what you've got in the box. Slightly different than I thought. It's going to be bigger than I thought because it's not pre-assembled. You've basically got to assemble it yourself, which does have the advantage, thinking about it, you could swap out the fans for some other branded fans if you wished. So for example, pressure optimized ones if you wanted, but that's obviously up to you. But it does come with the 2 fans to start with. First things first, let's start off. You've got your instruction manuals. It tells you how to basically fit it together, and then a little bit about the warranty on the back. Pretty straightforward. You've got that wide splitting cable. It's a 3-pin connection on there for these, so that means they'll plug into a 3-pin connection on your motherboard. Most 4-pin connections will allow a 3-pin connection, but it doesn't allow them to adjust the temperatures 100%, or should I say the fan speeds 100%, depending on the motherboard. Then you've got 6 of these screws. They're a bit like case screws, look like a fraction longer than a case screw, and then you've got 2 standard screws there as well. You've got what looks like 2 brackets. I'm guessing that's what you put over the fans to attach them together. A little sticker, not that that really bothers me. And then you've got the back plate with a little bit of mesh which will go over there. Ooh, get it the right way around. Which will go over there. Which these things never clip in 100%, do they? There we go. So that's in there, and it gives you a little hole there. What that hole's for, I ain't got a damn clue, to be honest with you. It's not as if there's a little switch to turn it on or off. So, well, there's a little hole. And what you want to use it for, well, that's up to you. You can stick your finger in there and do all sorts. But anyway, you want to attach the fans together. You've got to make sure you're going to be attaching them the right way around, first of all. So let's figure out which way these go. So obviously you're going to be wanting to blow the air upwards. So I'm guessing you would have it. So if you're wanting to blow air upwards, you'd be wanting the fans to blow that way, so you'd be wanting the labels pointing that way. So let's have the cables at the same side, so I'm guessing those go in there like that. And you put the bracket over the top and put in 2 screws there. 2 screws there. And find my screwdriver. And get the 2 at the other side. Okay, now that's screwed together. We need to attach that onto there. That's where I'm guessing we use another 2 of the larger screws. Not the easiest to do, because that needs to be higher up, so let's balance it on there. Get one of the long screws, that'll go in there, the other one will go in there. Okay, and that's basically it. That bit's just a tad bent, just push it into place. Yeah, so there you go. So that's what it looks like. So you've got 2 fans, they're attached firmly together, there's no flex in there, which is good. Those 2 cables there, the fan cables, you can attach them together. Obviously, depending on the way you mount the fans, which way round depends on which way your cabling's going to go, so obviously pre-plan that out. There we go, so that's in there. So, and then that'll plug into your motherboard wherever. Usually at the bottom, I would say, is probably the best bet. Well, again, every motherboard's different. But there you go, so that gives you a rough idea. That is quite a big unit. It's a lot bigger than I was expecting. I wasn't expecting anything of that size, so that's good. So yeah, so basically what it'll do then, we'll show you in action in a few minutes, but you'd have your graphics card in your computer there, this would slot underneath it, and then it'll blow the fresh air, obviously from the bottom of the case, into the graphics card. But we'll see if it actually does benefit or not, because it might make the graphics card cooler, but it could potentially be shifting the hot air to other parts of the machine which don't need it. Okay, so I have the cooler set up. It's in our test rig. I will do tests inside a case as well, but this will give us a rough idea, and then we know there's no other issues regarding other fans in the case causing any issues with the airflow. But we're running basically a 1060 graphics card, 6GB. It's running flat out, running Furmark, which you can see running on the screen here. This stresses the GPU flat out basically. It's currently running at roughly 71 degrees, which you can just see down here, and it maxed out at 71, so that's running as basically as hot as it's going to get. That's been running for about half an hour now. The rest of the machine doesn't really matter too much. It's basically a 10700K i7 processor. It does have just 8 gigs of memory in, because the cooler we've been testing at the moment has issues fitting any more RAM in there unless it's really low profile, but that's not going to affect this test. The cooler is currently turned off, okay? So we know that the graphics card gets up to 71 degrees Celsius while this cooler is turned off. As you can see, the fans are there. One thing to note, it is quite wobbly, okay? It's not the most sturdy thing, but it's not going to be if it's going to be that long and it's stuck on a mini little bracket on the end. It should be more than adequate to obviously do what we want it to do. Right, so if I was just to connect this up, again I wouldn't advise you do this normally, but I'm just going to hook up the fans directly to the header on the board. The fan I have set up to run at 50% speed. So it's going to create a little bit of noise, but a bit of airflow as well. So that's actually cooling down. So let's have a look at the cooling of it now. Let's see if you can see too well or not. But at this bottom left, I can see straight away the temperature's dropped down to 69 degrees Celsius. So it's dropped by 2 degrees already running at 50% of its speed. Again, after a few minutes, I'm guessing that'll drop down a bit more. It's now gone down to 68 degrees, so I'm going to give it roughly 20 to 30 more minutes, well, give it exactly 30 minutes, to see what temperature it's running at after 30 minutes, to see how much it has actually cooled it down, because now it's dropped down to 67 degrees Celsius, so that's 4 degrees difference altogether in a short period. So that's pretty good going, but I'm going to keep it running and we'll jump back in a few minutes and see how it is. Okay, so we're back after roughly 30 minutes. The temperature has dropped to a stable 65 degrees. It's been about that same temperature for about 20 minutes now. So we can safely say that's lowered the temperature by 6 degrees. For something so little in price, it's made the graphics card a lot cooler, which is pretty good considering the price. And that will allow you to potentially overclock the graphics card or make the graphics card last a bit longer, especially if you've got a case which is a little bit restricted through airflow and so forth. That's going to help you quite a bit. And again, this is with the cooler just running at 50% speed. I'm now going to go into the BIOS, so I'm going to restart the machine, stop the test, run it again, but this time with the fan running flat out. And as you can see here, I'm going to restart the machine, which is going to take a second or two. And hopefully, once we've managed to get back in, oh, here we go, it's popped up on the other screen, but so you can see it, we're going to go in there and change the fan speed of system fan 3 to full speed. And save it, start the machine back up, and then do all the testing again, and I'll come back in half an hour and basically see if, well, it's running any better. So let's just start the testing again. Obviously when we first start the testing, it's not going to be as hot as before because it obviously takes its time to get that far. And go. So you can see me starting the test there, and you can see the GPU straight away was 48 degrees, it shot up to 51, 52 and so forth. But hopefully with the fan speed on a little bit faster, so well 100%, it's going to keep it even more cooler, and if that's the case it will make a little bit no more noise for obvious reasons. Faster fans equals more noise. Same with anything in this life, if it goes faster it generally makes a lot more noise. So I'll pop back in 30 minutes and we'll see what sort of temperature we're getting then. Okay, so we're 30 minutes into the testing and we're running at 62 degrees. It seems pretty stable at 62 degrees for a little while. So that means when this is actually on 100% fan speed, it's reducing the temperature by roughly 9 degrees Celsius. When it's running at half speed, 50%, it's reducing the temperature by 5 degrees. But either way, that's making a huge difference in the temperature of this. It's making it nice and cool to touch, and I can't ask anything else from it. It might be a cheap device. It's not the most inspiring, it's not the best designed colour-wise, it doesn't have RGB, but it does what it says on the tin. It cools your graphics card down, and it does exactly that by up to 9 degrees we found with this one graphics card. Potentially if you used it with a bigger graphics card, let's just say something like a 3080, 3090 even, you could potentially be cooling it down by even more, or even some of the AMD cards which can get really hot, and that will potentially allow you to give it better overclocking and obviously a better lifespan, because the cooler electronics it keeps, basically the longer they last.